Section 4.2 Addition Rule and Multiplication Rule. A compound event is any event combining two or more simple events. For example, if I roll a die, my sample space will be 1, 2, 3, 4, 5, and 6. My event A will be the event of getting a 5. And event B will be the event of getting even numbers, which is 2, 4, and 6. Compound event can be the event of A or B, or the event of A and B. So these two are called compound events because it's combining between A and B. So event A or B means the event of getting a 5 or even. Event A and B means the event of getting a 5 and an even number. Addition rule. Addition rule is always used for the OR event. Whenever your compound event is connecting with an OR, we are using addition rule. Probability of A or B means probability in a single trial, event A occurs, or event B occurs, or they both occurred. The formula for addition rule: probability of A or B equals probability of A plus probability of B minus probability of A and B. Disjoint or mutually exclusive. Events A and B are disjoint if they cannot occur at the same time. For example, if I roll a die, my sample space is 1, 2, 3, 4, 5, and 6. I have event A represent the number 5. Event B represent even numbers. And event C represent odd number. We say event B and C are disjoint because they don't share any common element. Events A and B are disjoint because 5 and even, they do not share any common element. Event A and C are not disjoint because they both share a 5. Example 1. Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. In this table, I have 4 columns representing the number of orders from 4 different restaurants, and we call it A, B, C, and D. There are 2 rows representing the number of orders that are accurate and not accurate. When I'm given a table like this, I always find the total for each column, each row, and the grand total first. There are a total of 351 orders from restaurant A, total of 322 orders from restaurant B, 266 orders from C, and 166 orders from D. There are total of 972 orders that are accurate, 133 orders that are not accurate. The grand total is 1,105, which is your sample size as well. Question A. If one order is selected, find the probability of getting an order from restaurant A or an order that is accurate. I have a compound event that is connecting two simple events with an OR. I want to find the probability of restaurant A or an order that is accurate. To find probability of an OR, I am going to use addition rule. So I have probability of A plus probability of accurate minus probability of A and accurate. To find the probability of A, I will take the total number of orders from restaurant A divided by the grand total. To find the probability of accurate, I'll take the number of orders that are accurate divided by the grand total. To find the probability of A and accurate, I'm looking for the total numbers of orders that are from A and also accurate. These are orders from A. 315 are from A that are accurate, 36 from A that are not accurate. These are all orders that are accurate. 315 from A that are accurate, 272 from B that are accurate, 235 from C that are accurate, 150 from D that are accurate. I only want the number from A and accurate, which is 315. To find the probability, I take 315 divided by 1105. Since they all have the same denominator, all I do is just add and subtract the numerators. And I have 1008 divided by 1105, which is 0.912. There was no instruction, so I rounded to 3 significant figures. Question B. Are the events of selecting an order from restaurant A and selecting accurate order disjoint events? So I'm wondering if the event accurate and the event from restaurant A are disjoint. In order to do that, all you do is just looking into these two lines right here. The blue one representing the order from restaurant A, the orange one representing the order from accurate. If they have something in common, they are not disjoint. Or you can also look at the probability of A and accurate. If this probability is not 0, then they are not disjoint. Example 2. I'm given the same table, and the question A is asking if one order is selected, find the probability of getting an order from restaurant A or an order getting from restaurant B. I have a compound event that is connecting the two events with an OR. I am going to use addition rule. To find the probability of A, I take the total number of orders from A divided by the grand total. To find the probability of C, I take the total number of orders from C divided by the grand total. To find the probability of A and C, I'm looking for the total number of orders from A and also from C. These are orders from A, and these are orders from C's. They have nothing in common. They don't have any common element. That means there are no order that are from A and also from C, which is 0 over 1105. The probability of A and C is 0. And I have 617 over 1105 and 0.558. Question B. all the events of selecting an order from restaurant A and selecting an order from restaurant B disjoint, and why. These are the orders from restaurant A, and these are the order from restaurant C. They don't have anything in common. That's why A and C are disjoint. Or you can say the probability of A and C equal to 0. That's why A and C are disjoint. Complementary events and the addition rule. If you take probability of A and add it to probability of its complement, is equal to 1. We have 3 variations of the complement rule. First, P of A plus P of A bar equals 1, or P of A bar equals 1 minus P of A, or P of A equals 1 minus P of A bar. Example 3. I'm given the same table. Question A. If one order is selected, find the probability of getting an order that is accurate. My event is just getting an order that is accurate. To find the probability of getting an order that is accurate, I take the total number of accurate orders divided by the grand total. And I get 0.879638009. There was no instruction on how to round, so I'm going to round to 3 significant figures. This is a 6, so I round up. I add 1 to 79, that would be 80. Question B. If one order is selected, find the probability of getting an order that is not accurate. My event here is an order that is not accurate. The event of not accurate is a complement of the event accurate. So to find the probability of not accurate, I take 1 minus the probability of an order being accurate, which is 1 minus 0.880, and I get 0.120. Multiplication rule. Probability of A and B. This compound event is connecting with an n. That is when we are using multiplication rule. P of A and B means probability of event A occurs in the first trial and the event B occurs in the second trial. Probability of B given A represents the probability of event B occurring after it is assumed that event A has already occurred. This is the multiplication rule. To find probability of A and B, we take probability of A multiplied by the probability of B given A. Independent events. 2 events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other. If A and B are not independent, they are said to be dependent. Example 3. 50 test results from the subject who used drug are shown below. We have total of 50 people in the sample. 45, we have total of 50 people in the sample. There are 45 positive test results and 5 negative test results. Question A. If 2 of these 50 subjects are randomly selected with replacement, find the probability that the first selected person had a positive test result and the second selected person had a negative test result. Keyword, with replacement. With replacement means that after I select the first person, I will put him back into the sample, which means the first person can be selected twice. I want to find the probability that the first person had a positive test result and the second person had a negative test result. Because this is an n, So I am going to use the multiplication rule. Take probability of the first one had positive test result, multiplying by the probability of the second one had a negative test result, given that the first one is already positive. To find the probability that the first person had a positive test result, we take the total number of positive test results divided by the total, which is 50. Now, after the first person was selected, we put him back in here. So there are still 45 in here, there's still 5 for the negative test result, and there's still 50 people. I want to find the probability that the second person was selected with negative test result. So there are a total of 5 negative test results. We take 5 divided by 50. So I have 225 divided by 2500. And I get 0.09. B. Repeat part A by assuming that the two subjects are selected without replacement. Keyword, without replacement. That means once the first person was selected, we don't put him back into the group. I want to find the probability of the first one is positive and the second one is negative. I'm using the multiplication rule. Probability of the first person is getting a positive test result is 45 out of 50. Now, because we are selecting them without replacement, that means after I select the first person, he's gone. That means I only have 44 left here because the first person was selected. That means my total is 49. Now, I want to find the probability that the second person have a negative test result, given that the first person had positive test result. So the first one was already taken out. The probability of the second person has a negative test result is 5 out of 49. So I have 225 divided by 2450, which is 0.092. When you are selecting without replacement, the two events, first positive and second negative, are dependent because the first event affecting the probability of the second event. When we are selecting with replacement, these two events are independent because the first person was test positive does not affect the probability of the second one. Sampling with replacement, selection are independent. Sampling without replacement, selections are dependent. Treating dependent events and independent, 5% guideline. When sampling without replacement and the sample size is no more than 5% of the size of the population, treat the selections as being independent. For example, assume that 3 adults are randomly selected without replacement from the 247,436,830 adults in the United States. This is my population right here. And I select 3 people from 250 million. Also assume that 10% of adults in the United States use drugs. Find the probability that 3 selected adults all use drugs. So this selection is without replacement. In general, this is dependent. However, my sample size is only 3, and my population size is 247 million. If I take the sample size divided by the population size, which is 3 over 247,436,830, I have 0.000000012 1. Using the 5% guideline, if the sample size is less than 5% of the population size, we can treat this as independent. So this is less than 5%. I want to find the probability that all 3 selected adults use drugs. They also give me the information that 10% of adults in the US use drugs. So I want to find the probability that all of 3 of them use drugs. So I take 10%, which is 0.10 for the first person, times 0.10 for the second person, and times 0.10 for the third person, which I get 0.001.